Hello everyone, welcome back to the channel. Today we are going to solve this problem related to applications of derivatives. We are given this question which says a conical tent of given capacity has to be constructed. Find the ratio of the height to the radius of the base for the minimum amount of the convas required for the tent. That means while making this conical tent, we must use minimum amount of we just have to use that material. That means we do not use that material on the floor, right? All around the curved surface area of this conical tent. Let's make the figure at first. Let ABC be the conical tent with height h, radius r, and slant height l, as shown in the figure. After making the tent, its capacity is fixed. That means its volume is fixed. Therefore, volume V equals to 1 by 3 pi r square h. Let us express h in terms of B. So h will be equals to 3b by pi r square. Also, let total surface area of the conical tent be S. Therefore, this total surface area of the tent will be curved surface area of cone, which is equals to pi r l, or S equals to pi r root under r square plus h square, which can be expressed as s square equals to pi square r square into r square plus h square, or s square equals pi square r power 4 plus pi square r square into, instead of h we can write 3b by pi r square whole square, or s square equals to pi square r power 4 plus, we can write this as 9b square divided by r square, which is equation second. Now, differentiating equation second with respect to r, we get ds square by dr equals to r power 4 derivative will be 4r cube, right? So 4 pi square r cube, and 1 by r square derivative will be minus 2 by r cube into 9b square. That is ds square by dr equals to 4 pi square r cube minus 18v square by r cube. Let this be equation third. Yeah, equation third. So, if S is minimum, then S square will also be minimum. And For minimum or maximum value of s square, we must have equation third to be equals to 0. That is ds square by dr should be 0, or 4 pi square r cube minus 18 b square by r cube equals to 0, or this will be equals to 2 pi square r cube equals to 9 b square by r cube. That is, this will be r power 6 equals to 9 b square by 2 pi square, which implies r equals to 9 b square by 2 pi square power 1 by 6. Let this be equation 4. Again, differentiating equation 3 with respect to r, we get d square s square by dr square will be, so 4 pi square r cube, its derivative is 4 into 3, 12 pi square r square, right? 12 pi square r square plus 1 by r cube derivative is 18 3, 54 plus 54 b square by r power 4 plus 54 b square by r power 4. If you see the RHS side, for any value of r, okay, for any non-zero value of r, d square s square by dr square is always positive, right? That means here d square s square by dr square is always positive for r equals to 9 b square by 2 pi square power 1 by 6. So s square is minimum when r equals to 9 b square by 2 pi square 1 by 6, right? That also means, that implies s is also minimum for r equals to 9 b square by 2 pi square power 1 by 6, right? Hence r equals to 9 b square by 2 pi square power 1 by 6, or r power 6 equals to 9 by 2 pi square into b square can be written as 1 by 3 pi r square h whole square, or r power 6 equals to 9 by 2 pi square into 1 by 9 into pi square r power 4 h square. Cancelling all this pi square, 9 and 9. So r power 6, r power 4, this is r square equals to h square by 2, or r square by h square equals to 1 by 2. That implies r by h equals to 1 by root 2. So the required ratio of height of tent to the radius of its base is h is to r equals to root 2 is to 1. Answer.